Mr. Harris here, and welcome to a new video. In this video, I'm going to introduce to you the concept of fractional distillation. So here, in the previous videos, I mentioned that fossil fuels, of course, there are three major sources: coal, petroleum, and natural gas. But we'll be mostly focusing on petroleum here. Now, petroleum, it's a major source of fuel and it's an important raw material. But as I said, it's not really useful by itself. We can sort of Oh, before that, as I'll write it here, petroleum is a mixture of hydrocarbons. And I said individually, these hydrocarbons, they are useful because we can make them into like petrochemicals and many other like cosmetics or even pharmaceuticals. You can make them into drugs. But petroleum by itself, it's like a big chunk of mixture of hydrocarbons. It's not really that useful. So we need to find out a way to separate these hydrocarbons and make them useful. And this is where this process comes into place, which is called fractional distillation. Now, fractional distillation, what is that? Well, we have learned fractional distillation of liquid air in book 1A. I think it was chapter 2 or 3. And over here, of course, you can see the definition, but I prefer to use my own, which is basically separating substances. Well, in this case, we are separating the hydrocarbons. And what was the principle behind it? Like, how could we separate? At that time, we learned that we could separate nitrogen, argon gas, and oxygen gas. How was that being separated? Obviously, because they had different boiling points, right? Over here, it's the same thing. We can separate these substances with different boiling points. So this is the principle behind fractional distillation. And this process is done in obviously in a oil refinery. So like you have these huge factories, like these huge towers. Now this tall metal tower, it has a name to it. I think it's sitting here. Oh, okay. Maybe I'll just talk about this first. So with each fraction, so later on we'll learn that the hydrocarbons that are separated, we call them a fraction. They'll have a specific boiling point range, and because it is a mixture of many different hydrocarbons, yeah, we'll see that in a bit. All right, here. So these in the industrial areas, you'll find these very tall metal towers, and we call them fractionating towers. Now, it's not. Look, the process name is fractional, ending with an NAL, but the tower or where it actually occurs is called fractionating, so it ends with an ing. And sometimes you'll see that it's called fractionating column. So CO here. So just one reminder there, the process is called fractional distillation, but where it actually occurs is called fractionating tower or fractionating column. So here's the tower or the column that I was talking about. Now in each of these columns, you can see that there'll be a fraction that's separated. So these are the hydrocarbons that I was talking about, like petrol, naphtha, kerosene. And on the right hand side, you'll see that the number of carbon atoms that it has. So here, and as to remind you again, these are hydrocarbons. So you'll only find carbon atoms and hydrogen atoms. So these numbers here, they indicate just the carbon number, not the hydrogen number. And you can see the ones on the top, they're having a lower boiling point. The ones at the bottom, they're obviously having a higher boiling point. Okay, now let's look at the principle behind it. Like, how does fractional distillation actually work? And if you recall, actually, it's the same thing what we learned in book 1A. So first off, we need to get petroleum, which is a mixture of hydrocarbons, like this really huge chunk of hydrocarbons, which are not really that useful, and we're going to heat it up. And so you can imagine there's a furnace and you're heating it up, and my very ugly drawing of a fire, maybe I'll not draw it. And then afterwards, obviously after heating this huge chunk, imagine that it's become a vapor now. So it's like in a gaseous state. Let's imagine that. And you're going to pass it through inside this column, and those with a higher boiling point, those hydrocarbons with a high boiling point, you can sort of separate them out over here. So, example, first bitumen. Oh, by the way, this furnace, it's being heated at roughly around 400 degrees Celsius. So bitumen, it's above 350 degrees Celsius, so you can separate it out first. And then as you go higher up the fractionating tower or column, the temperature decreases. So the temperature is lower up there. So what you can do is, you can open, there's like this cap over here. You can open this cap and let all the hydrocarbons pass through. And then whatever the temperature is here, that particular fraction or that particular hydrocarbon will come out like fuel oil here. It's separated out here. And then you can open this cap and let the others pass through and keep doing this process till you go to the very end here and you get refinery gas. So that's the logic. So here you can see the vapor passing to cooler top via trays. So these are called, wait, I'll rip this part out. This particular section here, you can see that they're called trays here. So just imagine this is a tray here. And you can continue this process and basically you can get your hydrocarbons separated or your fractions separated. So it's better to use this word fraction now that we're learning about it. Now, at the end of the day, the hydrocarbons with smaller molecules and lower boiling points, they'll be collected at the top. So here, like refinery gas, petroleum, they're collected at the top. And those that are having a larger molecule, a higher boiling point, they'll be collected at the lowest, so at the bottom here. So like bitumen, lubricating oil, fuel oil, so on and so forth. All right. So some more things to mention here. Actually, we have a higher demand for those that are at the top here. So these fractions, they're actually the ones that will the lower boiling points, or I should say the lowest boiling point here. This is of higher demand. And those that have the highest boiling point, like bitumen, lubricating oil, actually the demand is not as high. So here I would say there's a lower demand in society. So, and later on we'll learn why. Because actually, refinery gas, we need to use it a lot for fuels. And petrol, we know for cars, we need petrol. But these here, like bitumen is actually used on roads. It's to make the road surface. So it's not really, I mean, of course, it's still useful, but it's the demand is not as high as using like fuels for transport. All right. And also here, these fractions, so I'm going to rub it out. So I'm expecting you're writing down this on your book. Oh, these fractions here, sometimes you'll see that they have different names. Like for example, refinery gas, sometimes it's also called LPG, or petroleum gas. So in the past papers, they've mentioned these words, so I'm just writing all of them for you. Petrol is petrol naphtha here. Now naphtha, please make sure the spelling is correct. It's NAPHTHA. And then kerosene, and then diesel, sometimes you'll also see it referred to as gas oil. Fuel oil, sometimes you'll also see that it's heavy oil. And lubricating oil, and sometimes you'll see wax is also somewhere here, wax. And at the end, it's bitumen. So these names, sort of, you gotta be familiar with them. And also, I would prefer that you sort of have the idea what are their carbon atoms number and what are their boiling point range. So roughly, I don't need you to know exactly these numbers, but roughly get the idea what these numbers are. Like for example, if I ask you, hey, what's in the 150 to 240 degrees Celsius range, and you can tell me it's kerosene, right? And I've sort of made a way for you to memorize these fractions. So it's just listen to it. Now, first of all, now just imagine that this petroleum gas. All right, I'll use this. There's a P and there's a P. So PP. So in Cantonese, you know, PP stands for baby, right? So baby. Now, what do babies do a lot? They like to take a nap, right? So you can see naphtha, the next word, naphtha. Okay, so now you can remember this story, this sort of story. As you know, I like making stories to make you memorize these things. All right, so PP takes a nap. And then what happens after you can imagine this baby has grown and this baby will go into kindergarten, right? K, G, or I could say kinder, K, D, and G. Because you know, kindergarten is spelled as KIND. So the D is from diesel and ERGARTN. The G is for kindergarten. Okay, so you'll remember, okay, after kerosene goes to kindergarten, so that means there's gas oil and diesel oil. Okay, and when he goes to kindergarten, now just imagine Mr. Harris is teaching in the kindergarten. So he meets Mr. Harris. So heavy oil is from my name, Mr. Harris. And then the student gets full marks. Full marks. So F and L, full marks. Okay. And then the last two, wax and bitumen, I think you can sort of we'll it's easy to know bitumen is the last one because um, it is it is what it is. We will know that it's for roads, so just remember that. But the rest of them here, you can use this story. I'll repeat the story again. There was once upon a time there was a PP, there was a baby, so P and P. Babies, as we know, they love to take nap. They like to take a lot of nap. And then the baby has gotten old now, not that old, but got into kindergarten. So K, D, and G here. And he had met Mr. Harris for whatever reason. I'm teaching in the kindergarten, so heavy oil, and that student got full marks, just like you guys will hopefully after watching this video. So full marks. And then wax the bitumen, I'll leave that for you guys. So here, there you go. These are the fractions, and please make sure you know all of their carbon atoms. They not all of them, but get the idea of their numbers and their boiling point ranges. All right, moving on. So some trends that we can find is that those that have more carbon atoms in their molecules. So obviously, if there are more carbon atoms, right, the larger the molecule. In other words, it's saying the molecular size is larger, right? Remember, we learned this in book 2C. When the molecular size is larger, then the van der Waals force would be stronger. Now, if the van der Waals force is stronger, that means the melting and boiling points would be higher. So here, same thing. I'll go back here. That is why lubricating oil, bitumen, fuel oil, why are their boiling points so high? Because we can use the same logic. Because their molecular size, you can see here, the number of carbon atoms so high, so much, right? So the larger the number of molecules, the larger the number of molecules, the stronger the van der Waals force, the higher the melting and boiling points. And obviously, the petroleum fraction with a lower boiling point will have a smaller number of carbon atoms in their molecules. Okay, so I'll move on. Oh, here, some trends that you would need to know. Here, obviously, at the bottom, bitumen, it will have the number of carbon atoms would be the most. The boiling point range would be highest. Why again? Because, again, as I said, the molecular size. So this is actually a typical question that they would usually ask, like why is the boiling point of bitumen lubricating oil so high? And then obviously always use the same answering technique. This is the answering technique. First, mention, maybe I'll write one, mention the molecular size is larger. So what? Then the second reason would be the van der Waals force would be stronger, or the intermolecular force would be stronger, is stronger, and that's why whatever the boiling points, the BP would be higher. Okay, and going down the fractions here, bitumen would be having the darkest color. It's the least likely to be evaporated because its boiling point is so high, right? So it's not going to be easy to evaporate it, nor is it going to be easy to burn it because it's having such a high boiling point. Its van der Waals force is so strong, and it's going to be the most difficult to flow. So it's viscous. Its viscosity is the highest. So it's not as you can imagine that it's not so thick. I'm sorry, it is very thick, so it's not going to be easy for it to flow around. Unlike the petroleum gas or petrol, they're going to have the smallest number of carbon atoms and so on and so forth. So this relationship, so these trends, these properties also sort of get some familiarity with them. All right, and then one more point, also there, the flame colors, as mentioned here, it's darkest here, right? But also, I would want to add something more. Um, there's going to be lots of soot for this also. So soot is like some dirt, some carbon particles that are like pollutants. So you can imagine some carbon pollutants there. Carbon pollutants. So we'll learn more about soot later on when we learn about combustion, but here you can imagine that. For the ones that are on the top, they're going to be less soot or no soot. So you can imagine that black substance that's formed when you like burn. Probably when you burn some charcoal or coal, you've seen that black substance. So sort of those type of soot that I'm talking about here. Okay. And then moving on, so some of the uses of these fractions, as I told you, for the ones that are having a lower, less carbon number of carbon atoms, they are having a higher demand because they're primarily used as fuels. And you can see that they can be used as gaseous fuel in your vehicles. Naphtha is also used quite often for manufacturing town gas. We'll learn that later on. But here, the lubricating oil and bitumen, there are not really as high of a demand, but obviously they still have their uses. So here, this part of their uses, please make sure you're also familiar with it. All right, now once we're done with that, now let's do some questions to wrap up this part. Now here first, part A. Which fraction has the lowest boiling point range? Obviously, the ones with the lower number of carbon atoms, they're going to have lower number of molecules. Their strength of van der Waals force will be less, so they're going to have the boiling point will be lower for it, obviously. So refinery gas here. State the two names of two petroleum fractions not given in the table. So you can just use that story again. So PP, remember the PP goes and takes, what do they love to do? They love to take a nap, right? You don't see the nap here. So there's no nap here, so you can write naphtha, and then you can just continue with the story. And then any two of the following, you can see naphtha, lubricating oil, or bitumen. Or I'll leave that for you. You can just write it by yourselves. And then part C, what is the relationship between the number of carbon atoms and the boiling point range? Oh, so it's talking about that same thing that we were talking about. The more the carbon atoms, the higher the boiling point. Why? Because molecular size increase, and we know the strength of van der Waals force would increase at the same time. So, which increases strength of van der Waals force. Or sometimes you'll see the word intermolecular force. That's the same meaning. And part D, describe how the color and viscosity of the fuel oil fraction differ from those of the petrol fraction. So fuel oil, it is lower. It is lower in the fractionating tower. That means it's going to have the viscosity and what was the other one? Viscosity and color. So you can just look at the trend. Look at the trend. So we have to go back. Look at the trend. The viscosity, obviously, it's going to be higher. The color is going to be darker as well. So you can just copy it back. So color, it's going to be darker than petrol, and viscosity is going to be higher. And finally, the petroleum fractions have many uses. Name two uses of these petroleum fractions. So primarily, I would prefer you write as fuels, or you can write for road surfaces, or even as lubricants. So those, you can just go through them. But the main point here that we wanted to mention today is petroleum. It's a mixture of hydrocarbons. By itself, it's not really that useful. You gotta use fractional distillation to separate them. And then those fractions, make sure you know their names, their spellings, and their properties. So that's it for this video. And then in the next video, we'll talk about combustion. So see you. Bye.